Good morning everyone. Welcome back to our online maths classroom. We just write down the notes now and the details will be explained in the coming class. Okay? Factors and multiples. And please write the heading divisibility rules. Divisibility rules. Okay, please write down divisibility rules. Okay, let's start. So, let's start with the rule of divisibility by 2. What is the rule of divisibility by 2? Yes, we all know, isn't it? Let's write. Okay, I will explain this in the coming class. Okay, rule of divisibility by 2. Rule of divisibility by 2. Okay, write down. A given number is divisible by 2. A given number is divisible by 2 if, what is the rule? If, yes, its last digit is either 0 or an even number. If its last digit is either 0 or an even number, isn't it? So, what about the number 35? Is 35 divisible by 2? No, why? Last digit is 5 and odd number, it is not divisible by 2, isn't it? Yes. Write down the examples. Example, number 234. Is it divisible by 2? 234? Yes. Why? In 234, what is the last digit? 4. And 4 is an even number, isn't it? Okay, please write down the examples. 234, 580, last digit 0, isn't it? 3898, etc. are divisible or not divisible? Yes, divisible by 2, isn't it? Okay, now let's write the rule of divisibility by 3. What is the rule of divisibility by 3? Do you remember? Yes. What is the rule of divisibility by 3? Yes, a given number is divisible by 3 if its sum of the digits is also divisible by 3. Yes, isn't it? Okay, please write. Divisibility rule by 3 or rule of divisibility by 3. Okay, write down. A given number is write neatly. Okay, this is meant for writing. This class is meant for writing only. Writing down the notes and it will be explained in the coming class. A given number is divisible by 3. A given number is divisible by 3 if the sum of its digits is either 0, digits is also divisible by 3, isn't it? If the sum of its digits is also divisible by 3. If the sum of its digits is also divisible by 3, isn't it? That is the rule. Here why I have used is here because we are speaking about the sum, and sum is singular, isn't it? Sum of its digits is also divisible by 3. Okay, let's write some examples. Write down the examples. Example A. Example A. Let's write down example A. If a given number is divisible by 3, what is the rule? If the sum of its digits is also divisible by 3. Let's check some examples. Example A. Example A. It doesn't work sometimes, this digit screen, that's why. Okay. Example A. Write the number. Please consider the number 546. 546. For checking whether it is divisible by 3 or not, what we have to do? Yes, we have to find out the sum of the digits, isn't it? Sum of the digits. Sum of the digits equal to, which are the digits in 546? Which are the digits in 546? 5, 4 and 6. So sum means 5 plus 4 plus 6 and is equal to 5 plus 4, 9. 9 plus 6, 15. Is 15 divisible by 3? Yes, isn't it? 15 is in 3 tables. So since 15 is divisible by 3, we can say that 546 is also divisible by 3. Understood? To write down, since 15 is divisible by 3, we can say that we can say that 546 is also divisible by 3. Okay, let's write example B. Let's write one more example. Example B, the number is 462. The number is 462. Example B, please write down example B. The number is 462. So we have to check whether this is divisible by 3 or not. For this, what we have to do? Yes, we have to find out the sum of the digits here. Okay, find out sum of the digits. Sum of the digits. Which are the digits in the number for 462? Yes, the digits are 4, 6 and 2. So sum of the digits means what? 4 plus 6 plus 4 plus 6 plus 2. What is it? 4 plus 6, 10. 10 plus 2, 12. Is 12 divisible by 3? Yes, isn't it? Is 12 in 3 table? Yes. So since 12 is divisible by 3, we can say that 462 is also what? Yes, divisible by 3. Okay, write down. Since 12 is divisible by 3, since 12 is divisible by 3, we can say that since 12 is divisible by 3, we can say that 462 is also divisible by 3. We can say that 462 is also divisible by 3. Okay? Yes. Now let's discuss the rule of divisibility by 4. Okay, in this, let's discuss one more example. One more example is needed, I think, here. See, write down the number is 200. See, the number is 238. See, 238. Here also, we have to check whether the given number is divisible by 3 or not, isn't it? We have to check whether the given number is divisible by 3 or not. So what we have to do for checking whether it is divisible by 3 or not? What has to be done? Yes, finding out the sum of the digits, isn't it? Okay, find out sum of the digits. Sum of the digits is equal to, what is the sum of the digits here? Which are the digits in 238? 2, 3 and 8. So sum of the digits is equal to 2 plus 3 plus 8. So what is the answer? 2 plus 3, 5. 5 plus 8. What is 5 plus 8? Yeah, 13. Is 13 divisible by 3? Is 13 in 3 stable? No. So what can we conclude from this? What can we conclude? Yes, since 13 is not divisible by 3, we can say that the given number is also not divisible by 3, isn't it? Yes, please write down. Since 13 is not divisible, since 13 is not divisible by 3, we can say that what is our number? Yes, 238 is also not divisible by 3. Is it clear now? Yes. Now let's discuss the rule of divisibility by 4. The rule of divisibility by 4. Okay. The rule of divisibility by 4 is, a given number is divisible by 4 if the number formed by its last 2 digits is divisible by 4 or last 2 digits are both zeros. So what is the rule for it? So just stop for a moment after this and listen carefully. What is the rule of divisibility by 4? A given number is divisible by 4 if the number formed by its last 2 digits is divisible by 4. That means in the number 2516, don't write now, stop writing and listen here. In the number 2516, what is the number formed by the last 2 digits? 16, isn't it? Is 16 divisible by 4? Yes, 4 4s are 16. Since 16 is divisible by 4, we can say that 2516 is also divisible by 4. This is the rule of divisibility by 4. Okay. And one more thing. 2800. Here, which is the number formed by last 2 digits? 0 0. If the last 2 digits are both zeros also, we can say that a given number is divisible by 4. That means 3500, 8300, 80,000, etc. are divisible by 4. Why? Here last 2 digits are both zeros. In all these cases, last 2 digits are both zeros. That means a given number is divisible. What about one? Let's discuss one more. 8,960. No, one more. 8,920. What about last 2 digit number formed by the last 2 digits? 20. Is 20 divisible by 4? Yes, we know, isn't it? 20 is in 4 stable. Since 20 is divisible by pardon me. Since 20 is divisible by 4, we can say that 8,920 20 is also divisible by 4. Is it clear? Okay, that is the rule of divisibility by 4. Now please start writing. Start writing. Rule of divisibility by 4. These divisibility rules are very, very important. You should learn it today itself. Okay. Rule of divisibility by 4. Rule of divisibility. Rule of divisibility by 4. For finding out the LCM, HCF, cancellation method, everything, this is very, very important. A given number is divisible by 4. Write neatly, okay. A given number is divisible. A given number is divisible by 4 if the number formed by its last two digits number formed by its last two digits is divisible. Number formed by its last two digits is divisible by 4. Divisible by 4, or one more condition is there. What is that? Or if the number formed by its last two digits is divisible by 4, or the last two digits are both what? Last two digits are both zeros, isn't it? Or last two digits are both zeros. Both zeros. Okay. If the number formed by its last two digits is divisible by 4, or last two digits are both zeros. Underline, if the number formed by its last two digits is divisible by 4, or last two digits are both zeros. Okay. What is the rule of divisibility by 4? Yes. A given number is divisible by 4 if the number formed by its last two digits is divisible by 4, or last two digits are both zeros. Is it clear? Now let's discuss some examples. Example A. Please write down example A. The given number is 5816. Here, which is the number formed by last two digits? Yes, what is it? 16, isn't it? Yes. Here, the number formed by last two digits, write neatly, okay. Number formed by last two digits equal to 16, isn't it? Since 16 is divisible by 4, we can say that the given number is also divisible by 4. Is 16 divisible by 4? Yes, isn't it? 16 is in 4's table. Since 16 is divisible by 4, we can say that What is the given number? 5816, isn't it? I think so, isn't it? 5816 is also divisible by 4. Is also divisible by 4. Example B. So what is the rule of divisibility by 4? A given number is divisible by 4 if the number formed by its last two digits is divisible by 4 or last two digits are both zeros, isn't it? Example B. Example B. Okay, write the number 9324. Here, what is the number formed by last two digits? 24. Is 24 divisible by 4? Yes, isn't it? So, we can write it like this. Since 24 is divisible by 4, since 24, why we have taken 24? Because why? 24 is the number formed by last two digits here, isn't it? Since 24, or in detail we can write. Please write. Number formed by last two digits equal to number formed by last two digits is 24, isn't it? That is 24. Since 24 is divisible by 4, is 24 divisible by 4 or 24 in 4's table? Yes, isn't it? Since 24 is divisible by 4, we can say that the given number 9324 is also divisible by 4, isn't it? We can say that 9324 is also divisible by 4. Understood? Okay. Now let's consider one more example. I have already informed you this Digi screen doesn't work properly. That's why it happened. So the straight lines often comes like this, I know, but please pardon. Okay, example C. $3,600. Here, last two digits are both zeros, isn't it? So the given number is divisible by 4 or not? Yes, isn't it? So we can say that. The given number is divisible by 4, isn't it? Yes. And next, write down similarly all numbers in which both the last two digits of zeros are divisible by 4, isn't it? All numbers in which last two digits of zeros are divisible by 4, isn't it? Okay, write down. Similarly, write the digits 8,900 1,35,000, 6,14,000, 65,000, 66,600, etc. are divisible by what? Yes, divisible by 4, isn't it? Okay. Now, can you say the rule of divisibility by 5? What is the rule of divisibility by 5? Yes, what is the rule of a given number is divisible by 5? What is the rule? If its last digit is either 0 or 5. Very easy, isn't it? Okay, now write down. Okay, write down. Rule of divisibility. Rule of divisibility by 5. What is the rule of divisibility by 5? A given number is divisible by 5 if its last digit is either 0 or an even number, isn't it? Write down. A given number, 0 or 5, not even number, isn't it? A given number is divisible by 5 if its last digit is either 0 or 5, isn't it? Either 0 or 5. Very easy, isn't it? How to check whether a given number is divisible by 5 or not? How to check? Just we have to check whether its last digit is 0 or 5. If that is the case, we can say that the given number is divisible by 5, isn't it? Okay, right. Example. 4,995, 6,330, 1,255, 8,135, 1,230, etc. are what? Yes, divisible by 5. Okay, this is the rule of divisibility by 5. Next we have the rule of divisibility by 6, but that is not needed actually. So because we know the rule of divisibility by 2 and 3, so that is enough for 6 also. First, a given number is divisible by 6 if it is divisible by both 2 and 3. That is the rule. That is not needed actually. Now let's discuss very important rule of divisibility by 7. This is very important. Just write the rule. It will be explained in the coming class. Rule of divisibility by 7. Rule of divisibility. Rule of divisibility by 7. Very important. Please write. For checking the rule of divisibility by 7, or for checking whether a given number is divisible by 7 or not, for checking whether a given number is divisible by 7 or not, divisible by 7 or not, 7 or not, we need two steps. We need two steps. Okay, we need two steps. And write down step 1. Step 1. Step 1 is find last digit. Find last digit into 2. And step 2. Now we got one product, isn't it? Subtract this product from the rest of the digits. Subtract this product. Subtract this product from the rest of the digits. Subtract. We got one product here while multiplying the last digit into 2. And step 2, subtract this product from the rest of the digits. Rest of the digits. So what we have to do, first find out the last digit into 2, then subtract this product from the rest of the digits. And next, if the answer obtained is divisible by 7 or the answer is 0, very important, it will be explained in the coming class. Now please write down the rule. Just write down the rule. If the answer obtained is here, not comma, full stop itself. If the answer obtained is divisible by 7, or if the answer obtained is 0, if the answer obtained is 0, we can say that the given number is divisible by 7. We can say that the given number is divisible by 7. Very important. First complete, write it down. It will be explained in the coming class. That means for finding out or for checking whether a given number is divisible by 7 or not, we need two steps. Which are they? First step, finding out the product of last digit into 2. First step, finding out the product of last digit into 2, isn't it? Second step, subtract this product from the rest of the digits. And if the answer obtained is divisible by 7 or if the answer obtained is 0, we can say that the given number is divisible by 7. So, what is the rule of divisibility by 7? Don't write, just listen. We have to find out last digit. In the step 1, we have to find out last digit into 2, isn't it? This is not for writing, just listen. Step 1, we have to find out last digit into 2. And this product has to be subtracted from what? Rest of the digits. Rest of the digits minus this product. And if the final answer is either 0, if the final answer is either 0 or divisible by 7, we can say that the given number is also divisible by 7. That is the rule of divisibility by 7. So what is the step 1? Step 1 is last digit into 2. Find the product last digit into 2. And in step 2, we have to subtract this product from the rest of the digits. And if the final answer is either 0 or divisible by 7, we can say that the given number is also divisible by 7. Let's discuss some examples. Okay, please write down example A. Example A. First number is 252. 252. Okay, listen here. What is the last digit in? What is the last digit in 252? Yes, here the last digit is 2, isn't it? And which is the number formed by rest of the digits other than 2? Then the number formed by rest of the digits is 25. Okay, so let's try to do this. Step 1. What is the step 1? In a rule of divisibility by 7, what is the step 1? Last digit into 2, isn't it? Last digit into 2. Into 2, that's equal to what? Which is the last digit here? 2. 2 into 2. What is the answer? 2 2s are 4. Okay, so we got step 1. And what is our step 2? Subtract this product from the rest of the digits, isn't it? Which is the number formed by rest of the digits here? 25. So in our step 2, what we have to do? Rest of the digits minus rest of the digits minus this product. Which is the product here? 4, isn't it? So let's subtract rest of the digits minus 4. So which is the number found by rest of the digits here? 25. So subtract, that's equal to 25 minus 4. What is 25 minus 4? Yes, 21. Is 21 divisible by 7? Yes, surely we know 21 is in 7 tables. 7 3s are 21. So since 21 is divisible by 7, we can say that the given number 252 is also divisible by 7. Have you understood how to check whether a given number is divisible by 7 or not? Okay. By practice, it will be very easy for you. By practice, you will be able to do fastly, and with in mind you can do. But now, what is the rule? Step 1, we have to find out the last digit into 2. And in step 2, this product should be subtracted from the rest of the digits. And if the final answer is divisible by 7 or 0, we can say that the given number is divisible by 7. So how can we conclude? Since 21 is divisible by 7, since 21 is divisible by 7, we can say that 252 is also divisible by 7. Divisible by 7. Okay. So let's consider one more example. Second number is example B, 343. 343 is the second number. In 343, what is the last digit? 3, isn't it? So let's start doing example B, 343. Example B, 343. Okay, let's try to do. Here, step 1. What is the step 1? In step 1, we have to find out last digit into 2. Which is the last digit here? Last digit is 3. And number formed by rest of the digits is, except 3, which is the number formed by rest of the digits? Yes, 34. Okay. So number formed by rest of the digits is 34. So in step 1, find out last digit into 3. Last digit into 3. That's equal to Sorry, last digit into 3, no, last digit into 2, isn't it? Last digit into 2. Last digit is 3 here, that means 3 into 2, 3 2s are 6. Okay, so in our step 1, we got the last digit into 2 as 6. And in step 2, what we have to do? Step 2, rest of the digits minus this product, isn't it? Rest of the digits. Rest of the digits minus this 6. Okay, so what is it? Number formed by rest of the digits is what here? It is, yes, 34 minus 6. 34 minus 6. What is 34 minus 6? Yes, 28. Is 28 in 7 stable, or 28 is divisible by 7? Is 28 divisible by 7? Yes, we know 28 is in 7 stable, so we can say that 28 is divisible by 7. So what can we conclude? Since 28 is divisible by 7, the given number is also divisible by 7. Is it clear? You have to write neatly. In this DigiPen doesn't work sometimes. That is why I am writing like this. Okay, you should write neatly. So what can we conclude? Since 28 is divisible by 7, we can say that the given number is also divisible by 7. So, understood? Since 28 is divisible by 7, we can say that what is our given number? Yes, 343 is also divisible by 7. Okay, understood? What is the rule of divisibility by 7? In step 1, we have to find out last digit into 2, and that product has to be subtracted from the rest of the digits. And if the answer is either 0 or divisible by 7, we can say that the given number is also divisible by 7. Okay, let's try one more example. Write down example C. The given number is, so let's check, 147. The given number is 147. So let's start doing. What is our step 1? In step 1, we have to find out the last digit into 2. Which is the last digit here in 147? 7. And which is the number formed by rest of the digits? 14. Isn't it? Number formed by rest of the digits is 14. So step 1 is what? Last digit into 2. Step 1 is last digit into 2. That is equal to 7 into 2. 7 2s are 14. Isn't it? And number formed by rest of the digits is 14. Isn't it? What is our step 2? In step 2, we have to do the number formed by rest of the digits minus this 14. Isn't it? So what is step 2? Rest of the digits minus 14. Rest of the digits minus 14. Okay. So what is the number formed by rest of the digits? Here it is 14. So that means number formed by rest of the digits minus 14 is equal to 14 minus 14. Isn't it? What is 14 minus 14? 0. So what is the rule of divisibility by 7? If the and final answer is either 0 or divisible by 7. So if it is 0 also, we can say that the given number is divisible by 7. Understood? If it is 0 also, we can say that the given number is divisible by 7. So since the answer is 0 here, since the answer is understood, if it is 0 or divisible by 7, we can say that the given number is also divisible by 7. So since the answer is 0 here, 0, we can say that the given number is divisible by 7. Divisible by 7. This rule of divisibility by 7 is not in your textbook, but I think it is really useful for you for doing the cancellation method and LCM, HCF and all. That's why it is given to you. Learn it thoroughly and do many problems regarding this. It will help you to find out whether a given number is divisible by 7 or not without doing the division. Okay, without doing the division, regular division. So let's try one more example. Example D. The question is 481. 481. So here, which is the last digit? Last digit is 1. Which is the number formed by rest of the digits? The number formed by rest of the digits is 48. Isn't it? Here last digit is 1. Last digit is 1 and the number formed by rest of the digits is 48. 481. Last digit is 1 and the number formed by the rest of the digits is 48. Okay. So let's try to do. Step 1. Step 1. By practice, we can avoid all these steps. Without writing the steps, you will be able to do in mind by practice. Okay. Step 1. Last digit into 2. Last digit into 2. Here our last digit is 1. That means last digit into 2 means 1 into 2 is equal to 2. Isn't it? Number formed by rest of the digits is 48. So, what is step 2? Rest of the digits minus this product. Isn't it? Step 2. Rest of the digits minus rest of the digits minus this product, which is the product here, product obtained here 2. So that means 48 minus 2, isn't it? So that's equal to 48. This doesn't work sometimes, that's why. Okay, it's equal to 48 minus 2. What is 48 minus 2? 48 minus 2 is 46. Is 46 divisible by 7? Is 46 in 7 stable? No, isn't it? 46 is not divisible by 7. 48 minus 2, the answer is 46 and 46 is not divisible by 7. So from this, what can we conclude? Yes. Since 46 is not divisible by 7, we can say that the given number 481 is also not divisible by 7. Understood? What can we conclude from this? Is 46 divisible by 7 or 46 in 7 stable? No. So, what can we conclude? Yes, since 46 is not divisible by 7, we can say that the given number is also not divisible by 7. Understood? Okay, write down. Since 46 is not divisible by 7, not divisible by 7, we can say that the given number is also that means we can say that the given number means 481. 481 is also not divisible by 7. We can say that 481 is also not divisible by 7. Okay. Not working sometimes. is also not divisible by 7. Not divisible by 7. Okay, this is the rule of divisibility by 7. Next, we need not learn the rule of divisibility by 8. Now let's discuss the rule of divisibility by 9 now. What is the rule of divisibility by 3? Yes, what is the rule of divisibility by 3? A given number is divisible by 3 if if the sum of its digits is divisible by 3. The rule of divisibility by 9 is also the same as that of 3. The rule of divisibility by 9 is also the same as that of 3. That means a given number is divisible by 9 if the sum of its digits is divisible by 9. That is the rule. Okay, write down rule of divisibility by 9. Rule of divisibility by 9. Rule of divisibility by 9. A given number is divisible by 9 if, write down, a given number is divisible by 9 if the sum of its digits is a given number is divisible by 9 if the sum of its digits is divisible by 9. If the sum of its digits is divisible by 9. Okay, same as that of 3. Same as that of the rule of divisibility by 3. A given number is divisible by 9 if the sum of its digits is divisible by 9. So let's try some examples. First one, 639. Let's find out 639. Example A. 639. So what we have to find out? Yes, we have to find out the sum of the digits. Which are the digits in 639? Which are the digits? Yes, 6, 3 and 9. So find out the sum of the digits. Sum of the digits equal to sum of the digits is equal to 6 plus 3 plus 9. What is 6 plus 3? 9. 9 plus 9? 18. Is 18 divisible by 9? Yes, 18 is in 9's table, isn't it? 2 9s are 18. So since 18 is divisible by 9, we can say that the given number is also divisible by 9. Understood? Yes. Very easy. Since 18 is divisible by 9, since 18 is divisible by 9, we can say that we can say that 639 is also divisible by 9. Okay, 639 is also divisible by 9. Understood? Let's consider one more example. Example B. The number is 2736. B. The number is same as that of the rule of divisibility by 3, isn't it? So example B, 2736. Here also find the sum of the digits. Sum of the digits is equal to sum of the digits is equal to, which is the sum of, what is the sum of the digits here? Sum of the digits is equal to 2 plus 7 plus 3 plus 6. Okay. 2 plus 7, 9, 9 plus 3, 12, 12 plus 6, 18. Here also we got 18. Is 18 divisible by 9? Or is 18 and 9 stable? Yes. So what can we conclude? Since 18 is divisible by 9, since 18 is divisible by 9, we can say that which is our given number? Yes, 2736 is also divisible by 9. Divisible by 9. I think it is enough. The concept is finally clear now. Okay, so let's move on to the next rule of divisibility. What is the rule of divisibility by 10? We all know what is the rule of divisibility by 10. Yes, a given number is divisible by 10 if its last digit is 0. That's all, isn't it? A given number is divisible by 10 if its last digit is 0. That is the rule of divisibility by 10. Okay, now let's write rule of divisibility by 10. Rule of divisibility by 10. What is the rule? A given number is divisible by 10 if its last digit is 0. That's all. A given number is divisible by 10 as I have told earlier, I am using this DigiPen. That's why writing like this. You should write neatly. A given number is divisible by 10. What is the rule? If its last digit is 0. If its last digit is 0. That's all. So let's write some examples. A number having last digit as 0 is divisible by 10. That's all. Okay. So let's write some examples of this. Example 330, 2580, 910, 34,150, etc. are divisible by 10. Only one condition is needed for a number to be divisible by 10. What is it? Yes, its last digit should be 0. Etc. are divisible by 10. Etc. are divisible by 10. Okay, let's discuss the rule of divisibility by 11 here. Now stop writing and listen carefully. This is very, very important and little bit tough. You may get confused. So listen carefully, stop writing and listen. Now we are going to discuss the rule of divisibility by 11. So let's consider a number 1232. This is a 4-digit number, isn't it? So stop writing and listen carefully. Consider a number 1232. Here we are going to divide the number as digits as first place. Which is the first place digit on first place, or which is our first place? Ones place. So let's 1 is an odd number, so let's name ones place as odd place, and second place is tens place, and second place means second. 2 is an even number, so let's mark second place as even place, and third place again odd place, and fourth place even place. Like that we are going to name the places. Understood? We haven't done like this before, so how we have to mark the places here? First place as odd place, second place as even place, third place odd place, then again fourth place even place, like that. If so, in the case of 3,14,812, how can the places be marked like this? First place odd, we should begin with odd, second place even, then odd, even, odd, even. Understood? Clear? In the number 3,14,812, which are the digits on odd places? Which are the digits on odd places here? 2 is a digit on odd place, and 8 is a digit on odd place. 1 is a digit on odd place, isn't it? Don't think, ma'am, 2 is an even number, then why ma'am says like this? I'm talking about the odd place and even place, not the odd number or even number. Understood? Not the odd or even numbers. I am talking about the digit on odd place and digits on even places. In the number 3,14,812, which are the digits on odd places? 2, 8 and 1 are the digits on odd places. And in the same number, which are the digits on even places? Even places, yes, 1, then which comes 4, and 3 are the digits on even places. 3 are the digits on even places. Have you understood the difference? We are not talking about odd number or even number, odd and even numbers. We are talking about the digit on odd place and digit on even place. So let's consider one more number. 15,89,449. This is a number. So how can the numbers be named like odd and even? Digits be marked. First place, odd place. Second place, even place. Clear? Third place, odd place. Fourth place, even place. Then odd place, even place, odd place. Let me remind once again, we are not discussing about the odd numbers and even numbers. We are talking about the digits on odd places and digits on even places. So which are the digits on odd places here? 9, then 4, then comes our 8, 1. These are the digits on odd places. Which are the digits on even places? 4, 9 and 5 are the digits on even places. Here 9 is an odd number. Still it comes under the digits on even places. Understood? So first step for finding checking whether a given number is divisible by 11 or not, what we have to do? First step, we have to mark the numbers as odd and even. Digits as odd place, even place, like that. In step 2, we have to find out the sum of the digits on odd places. Understood? What is the step 2? Sum of the digits on odd places and minus sum of the digits on even places. What we have to do? We have to find out the sum of the digits on odd places and sum of the digits on even places, and find the difference. Sum of the digits of odd places minus sum of the digits on even places. And this, if this answer is either 0 or divisible by 11, and if this answer is either 0 or divisible by 11, we can say that the given number is also divisible by 11. That is the rule of divisibility by 11. Understood? First, what we have to do? We have to name the places as odd place, even place, like that. Then find out the sum of the digits on odd places. Then find out the sum of the digits on even places. Find their difference. If this difference is either 0 or divisible by 11, we can say that the given number is also divisible by 11. So let's consider one example. 1232. So what is our first step? Mark the digits as odd place, even place, like that. First place odd, second place even E, third place odd O, fourth place even E. So here which are the places on, which are the digits on odd places? 2 and these 2 are the digits on odd places. Which are the digits on even places? These 3 and 1 are the digits on even places. Okay. After marking like this, what we have to do? Find out the sum of the digits on odd places. So let's find out the sum of the digits on odd places. Sum of, no, not the sum of odd numbers. Sum of the digits on odd places. Which are they? 2 plus 1 equal to 3. Isn't it? Which is the sum of the digits on even places? Now let's find out the sum of the digits on even places. Which are the numbers on even places here? 3 and 1. So find out sum of the digits on odd places means 2 plus 1 made. Let's discuss once again. I had a confusion here. Sorry. Pardon. Let's discuss 1232. 1232. So sum of the digits on, first step, mark the number, mark the digits as odd place, even place, odd place, even place, odd place, even place, odd place, even place. Now digits on odd places 2 plus 2 and 2. Digits on even places 3 and 1. Okay. Sum of the digits on, this is not for writing, let's just listen carefully. Sum of the digits on odd places. Okay, sum of the digits on odd places means 2 plus 2 equal to 4. Okay, sum of the digits on even places. Sum of the digits on even places. Even places equal to what? 3 plus 1, that's equal to 4. Okay, we have to find out the difference of these two. Find out the difference. Find out the difference. Okay, difference is equal to 4 minus 4 equal to 0. Since this difference is 0, we can say that the given number is also divisible by 11. Okay, let's write down the rule. Okay, next, rule of divisibility by 11. Rule of divisibility by 11. Write down. Rule of divisibility by 11. If the sum of the digits on odd places, if the sum of the digits on odd places minus sum of the digits on odd places minus sum of the digits on even places, sum of the digits on even places sum of the digits on even places is 0 for a given number. Sum of the digits on even places is 0 or divisible by 11 for a given number is 0 or divisible by 11. Sorry, let me write once again. If 0 or divisible by 11 not working sometimes. Even places is either 0 or divisible by 11, either 0 or divisible by 11 for a given number, we can say that the given number is divisible by 11. We can say that the given number is also divisible by 11. We can say that the given number is write neatly, okay, number is divisible by, the given number is divisible by 11. This is the rule of divisibility by 11. So what is the rule? That if the sum of the digits on odd places minus sum of the digits on even places is divisible by 11 or 0, we can say that the given number is divisible by 11. So let's write some examples. Example A, 1232. Example A, 1232. Example A. Example A, 1232. So first step is what? This number has to be named as odd place, even place, like that, isn't it? First place, odd place; second place, even place; third place, odd place; fourth place, even place. So then what we have to find? Find the sum of the digits on odd places first, okay? Sum of the digits on odd places. Which are the odd places digits here? 2 and 2. 2 plus 2 equal to 4. Okay, sum of the digits on odd places is equal to 4. Next we have to find out sum of the digits on even places. Next find out sum of the digits on even places. What is it? Yes, 3 plus 1, that's also equal to 4. Then their difference. So next step, their difference. What is it? Equal to 4 minus 4, that's equal to 0. Understood? So we can say that since the difference is 0, we can say that the given number is divisible by 11. Understood? Since the difference is 0, we can say that the given number is divisible by 11. Okay. Since the difference is 0, since the difference is 0, since the difference is 0, we can say that the given number is divisible by, the given number is divisible by 11. Divisible by 11. So, what is the rule? Sum of the digits on even places, odd places minus sum of the digits on even places is either 0 or divisible by 11. We can say that the given number is divisible by 11. Okay. Let's consider one more example. Example B. Write down example B. Rule of divisibility. Divisibility rules very important. Without knowing these rules well, you won't be able to do the cancellation method well, or the LCM, SCF, all those things. So prime factorization and all such things. This is very important. Learn it thoroughly. I shall call you randomly and ask the rules, so you should be able to answer. Next, consider the number 429. 429. So here what we have to do, sum of the digits on odd places minus directly in one step. Let's do. Let first mark the numbers as odd place and even place. Mark the digits as odd and even places. 429. First place, odd place. Second place, even place. Third place, odd place. So let's find out the difference. Sum of the digits on odd places minus sum of the digits on odd places minus sum of the digits on even places. Sum of the digits on even places has to be found. So in working column, let's find out the sum of the digits on odd places. So let's find out the sum of the digits on odd places in the working column. Which are the digits on odd places? 9 and 4, isn't it? So 9 plus 4 equal to, what is it? 13, and this is odd. Okay. Sum of the digits on even places, only 2. 2 only is there. Only 2. Okay. Here we are finding out it in the single step. So the other calculation has to be done in the working column. Sum of the digits on odd places has to be found in the working column. That's equal to 9 plus 4 equal to 13. Sum of the digits on even places is equal to, only 2 is there, 2. Okay. So this difference means what? So this difference is equal to 13 minus 2. What is 13 minus 2? 11. Is it divisible by 11? Yes, 11 is surely divisible by 11. So since 11 is this is divisible by 11, we can say that the given number is also divisible by 11. Two conditions are there, either 0 or divisible by 11. Okay. Since this difference is divisible by 11, Since, or like this we can write 11 is surely divisible by 11. Divisible by 11. We can say that the given number or the number 400, what is the number? 429 is also divisible by 11. 29 is also divisible by 11. Is also divisible by 11. So let's wind up the class here. Thank you. Have a nice day.